Let's look at example number 31 on the sheet that we have up. That's an example of a dangling else. Let me show you what a dangling else is. Okay, so here's the deal. And the if-else is easy. There's just a couple of weird things that can happen, and that's what I'm, telling you about, because writing if-elses are very easy to do, okay? So this is an example of a dangling else, and let's see what I mean by this. So this is example number 31 on the first sheet that I gave you, okay? And what we have is this is a perfectly legal statement. We have a bunch of if-elses and this guy's here. I'm missing a semicolon, I just noticed now. This guy's here. And this guy's here. Okay. All right, so the dangling else is actually right here. And what a dangling else means, we have an else and we're not sure who it goes with. Okay? So the else in this case that's dangling is the now, the see out now. Because I put the else so that it would go with the I less than j. But in actuality, the rule of the dangling else is it matches the nearest unmatched if. So actually the way I've indented this is incorrect, and the way it should be indented is the way it is on your sheet. Let's make sure we understand that. Blah, 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 right? Okay? So what's a dangling else? It's not clear which if the else goes with, okay? And in this case, it could either go with the M and N scenario, or it could go with the I and the J. If we've learned nothing, we've learned that indentation is important, but it doesn't affect the logic. It's there to help you and future programmers and to make me happy, okay? But it does not affect the logic. So even though I've indented this else, that it looks like it goes with the I less than j, what is the rule with the dangling else? The nearest unmatched if. So that means that this else actually goes with this guy right here. Now by unmatched, let's see the difference in the scenarios. What about if I put braces around here? Now clearly that is only, there's not the unmatched if is no longer, everybody sees which if this goes with, because this if is done. So it's done, so it would never go with that one. Do you understand what I'm showing you? Okay. So that's not a scenario of a dangling else, because that if is matched, the second if. Okay, so I think I've covered everything. Let's start doing problems, and that's essentially what I want to do for the next, until we have the test, and just practice, practice, practice with you're going to need to be able to do two things. You're going to need to be able to trace code or give me the output, and you're going to need to be able to write code. So we need to be able to do both so that we're, till we feel really comfortable with it. So if you already printed out the selection, I'm going to bring up the selection exercises. And these are on the syllabus, by the way. There's nothing I'm giving you that is not.
So what's the answer to 31?
Okay, so the answer to 31, all right, should we finish that one? Okay. All right, so let me put it back the way it was. Let's finish. We're going to finish with 31 on the, and let's see. I'm just going to go ahead and assign. It was int I equals 6, semicolon, right? Int j equals 7, semicolon, and int m equals 8, semicolon, and int n equals 9, semicolon. Okay, so before we run this, why doesn't everybody take a second and see if they can give me the output? Because it's, all right? So everybody take a look at 31 and see if you can figure out the output based on what we've just learned about the dangling else. So take a minute and give me the output for number 31 on the review sheet. And everybody should have written one thing on their page to begin with without even thinking, right? What should everybody have written on their sheet right off the bat? Madam, okay? So we all wrote madam, okay? And then we're going to check to see if I is less than j, which it, of course, is. So we go into the m not equal to n, which, of course, that is true also. So what's the next thing that gets output? How? And then what's the next thing that gets output? I am. And then I greater than or equal to m is false. So we get Adam. So this would be the type of problem I would give you. I would change the numbers. You know what I mean? So, I mean, there's no surprises. I'll just be giving you different numbers. You have to know how to do these. Okay? Just the, oh, no, well, no. Well, you have to write code, yeah. Yep, so look at the thing I just gave you, and that's writing code, and that's the type of thing. Is this what everybody got? Madam, how I am Adam, is that what we said? Okay. Okay, so now let's write some code. We need to be able to do both, right? So the first one of these is really easy. So, you know, usually I start, so go ahead, write the first one. Don't write the declarations. If you don't know how to declare, you know what I mean? Like, don't waste time on that. Get to the logic. Okay? So the purpose of this is to be able to practice these so we all can do it. Question, Justin? You need another one? Selection exercises? I thought he came and got some. Who else needs selection exercises? You need them too? Okay. There should be 60. Any extra selection exercises coming around? Do you guys have selection exercises? You have it. Can you pass it over to, it's Ben, right? Okay. Okay, so we are now looking at these. Not these. These, as I mentioned, let me bring up in the syllabus for the recording that we are looking at these selection exercises. Everything I give you is always on the syllabus. So this is what we're doing right here. And maybe what we'll do is we will have people come up and answer these so that we can. David? Okay, so the first one is true. I less than j is true. So we enter this whole if else because we determined that that else goes with this if. Okay? That else goes with this if because that's the dangling else issue. Okay? So now we enter this guy, and m is not equal to n, which is second one's false. Okay, did I do the second one? I guess I did. So it's, oh no, the first one. Oh, you're doing the second one. I'm sorry, you're doing the second one.
No, I'm working on the first one.
Okay, the first one. So
What I'm saying is that
This one is true, this one is false. So you come, true just gets you into the whole guy. Okay? If this one is, okay, so then you reevaluate again. So now you come here. If this one is false, then you're going to do this now. Make sense? Okay. Can, how do you want to do this? Everybody's going to have to put something up here somewhere along the semester. So can we work on a system? And here's my advice to you. Do something easy that you know the answer to before waiting for me to call on you, something you don't know the answer to. So who wants to put number one up? We got number one, number two. Okay? So after he's done one, we're just going to start typing these, and you can come up and make sure everybody, like I said, if you know the answer, this would be a good one to pick rather than waiting until it gets hard. Keep working, and then we'll keep putting these up, and basically when he's done, you'll do number two, and we'll make sure that everybody has the solutions to these. Input, well, all I want is the if. All I want is the if. Oh, no, I'm sorry. It says input an age, so you have to input an age. Yeah. Whatever it tells me, it says input an age, so you have to input the age above it, right? See how it says input an age? So say C and age, yeah. Whatever it says. But you don't have to worry about declaring. Gurdeep? Okay, so number 3, okay, you finished number 2. So now what I want you to change is the 21. I want you to make a constant for the 21 in case that ever changed. So do you remember how to declare a constant? Okay, so declare a constant. Well, in that case, you're going to have to make a constant, okay? Perfect, okay? So number 2, Chris is going to do. And then who's going to do number 3? It sounds like Gurdeep's going to do it. Brandon, question? The arrows, oh, yeah. Can you fix the C in arrows? You get a syntax error. The way to remember that is, I have trouble remembering it. I remember where the data is going. So the arrows point where the data is going. So in the case of the input, they're going into the variable. In the case of the output, they're going out to the screen. So that's how I remember which way to put the arrows. But you're just going to get a syntax error. The compiler will tell you. Yep. So you declared a constant. Okay, so now rewrite that problem so that instead of using 21, you're going to say legal drinking. That's exactly right. So you're going to put that one up right next, right? And the good news is, go ahead. You can write it on paper. You can do whatever you want with it. I'm not collecting it. This is just for your. You can do whatever you wish. Okay, so then Gurdeep's going to come up and fix this with. All you're going to do is copy and paste and just do the constant declaration. Okay. So because she's already solved it, so you're going to redo the problem, copy and paste it, and solve it with the constant. Okay, so we're all doing okay. We're seeing the solutions here, but don't wait for them to do it. Do it yourself. Okay, so you want to use a constant for number 3. So we're going to declare a constant for the 21 with the idea that perhaps one day that'll change. I don't think so. But it used to be 18. So if you had that in your code, you would have had to change all the 18s, right? So this time he's going to make a constant for the, yeah, and you're going to put the declaration above it, right? No quotations. That would make it a string. I'm glad he's doing this because you guys can see, okay? So he's going to make a constant for legal drinking age, and he's going to do that above. Now, do you see the advantage of why that's a little bit better code? Because therefore, if the 21 ever did change, you only have to change it in one place, okay? So this is a better way of writing that code. Does that make sense? Yeah. Okay, what did we say it was for C++? Const or constant? I forget. Const. Java, I think, uses constant and... Oh, there, it told us because it turned blue. Yeah, okay. And then, okay. Does everybody see why this is a better solution to this problem? Okay, good. Perfect. Okay, thank you. Okay, and then we're down to 4 and 5. So do we have anybody who's completed number 4 or number 5 that would like to put it up here? So everybody's doing this at their seats. Don't wait for this. Do it yourself. You're not going to learn unless you write it. Don't wait for it. Write the code. Everybody can write this. Here? Okay. So who's going to do 4? William, can you do 4? Thank you. Now, do you think a constant would be good here too? What's, no? What's freezing? 32. So let's do a constant. So you can do copy and paste it and do a constant. I threw you off, didn't I? Yeah. Okay, and then if you've already done 4, who wants to do 5? Anybody ready to do 5? Tyler will do 5. Okay. Freezing. Freezing. A lot of smart Alex, aren't there? Okay. So, all right, so that's freezing, and then above, how about above? If you've done number 5 for 2 integer values and you're printing which is largest, let's also take care of the scenario for where they're the same. So let's do number 5. Let's do an extension to number 5. Let's do greater than, well, wait a second. The largest is, let me hold that thought. I'll put it up there. Now, why would I mean, you could use a constant here, not that the temperature of freezing is ever going to change, right? I mean, that's not going to happen. But it's not a bad idea. It makes your code clearer. So you could say the freezing temperature equals 32 and make that a constant as well. It just makes it nice and readable, okay? So using a constant would not be a bad idea in this example, okay? Okay, so for number 5, input 2 temp. Did everybody finish number 5? 2 values, 2 numbers, which is the largest? What would happen? What should happen if they're the same? So let's say you enter 5 and 3. What should it print? 5. Let's say you enter 3 and 5. What should it print? And let's say you enter 5 and 5. What should it print? Right. So that one's actually fine. Okay. So let me. I'm going to make a constant here, just to show you the other option. So let's say that we. Yeah, that's good point. Okay, so let's do the next one, and then I want to. Okay, so we've got cin num1 and num2, and then if num1 is greater than num2, we see out num1, else see out num2. Okay, so let's say we want to redo this problem so that we want to say whether which one's larger, which one's smaller, and whether they're the same. So try to write the code for that. So how would I phrase that? Let's see. So we're going to call this 5A. Input 2 integer values, print out whether they are okay. Where do you want? Number 4? Would you have a question? I just made a constant. Okay, so what should I do for this guy? What should my second else be if I want? What should this be? And what should this guy be? So either num1 is greater than num2, num1 is less than num2. What is my last guy going to say? But do I need to say that? Do I need to say that in the else? No. Because that's the only other possibility. Does everybody see that? Question, Ben? Yeah. So remember, it's technically what it is this. Okay, but I don't like that because it's not pretty because it's really a three-way test. So there's many scenarios where I'm going to do the following. Okay. Okay, so I've covered everything with if, else, and switch. Start doing your homework is what I would recommend. Okay. You should be able to do all the homework now. The best way to get familiar with this stuff is just to try a lot of problems. And, I'm going to give you more. We're going to go back over this on Tuesday. And we'll be able to handle anything that you're given. Okay? Any questions? Michael? That's not necessary. That would be an extra test, so don't. That would not be, that would be worse code. So that the clean way to write that is the way this is. Except I didn't indent it right. Okay, let me turn off.